To show you how to solve Leetcode question 235, lowest common ancestor of a binary search tree. So given a binary search tree, find the lowest common ancestor LCA of two given nodes in the BST. And this is Wikipedia's explanation. The lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P, Q as the descendants, where we allow a node to be a descendant of itself. So basically, like the common find a common parent of P and Q in this example. If you look at this tree here, P equals to 2 and Q equals to 8, and their lowest common parent is the root, basically is 6. And if you pay attention to the detail here, it's a binary search tree. So the characteristic of a binary search tree is all the left node is smaller than the root and the right node is bigger than the root. If you look at the number here, 2 is smaller, A is bigger than 6, right? And if you look at here, on the left side, A7 is smaller than A, but 9 is bigger than A. But everything on the right side, 7 is also bigger than 6. That's a binary search tree. So LCA of nodes 2 and 8 is 6. And there's another example here. P equals to 2, Q equals to 4. So in this case, their lowest common ancestor is 2 because 2 can be a descendant of itself according to the LCA definition. And then the next example is root equals to 2, and then there's a child node as 1. So it's like 2 is here, 1 is here, right? P equals 2, Q equals 1, and then the output is 2 because 2 is the itself. It can be a descendant itself according to the LCA. So here are some constraints here. And this is a question asked by a bunch of companies, especially LinkedIn 17 times in the last 6 months. It's an easy question, but I feel like it's a good question to practice on. So if you take a look at this example here, we can find something in common is that if the node is smaller than the root, and if P is smaller than the root and Q is bigger than the root, so even it's here, right? Even let's say the P is 0, Q is 9, their common ancestor is still 6 root. And if you pick anything on the 3 here and the 3 and 9, the lowest common parent is still the 6. So you can see this is exactly what we're trying to find, because if P is on the left side of the tree, Q is on the right side of the tree, because it's a binary search tree, everything is kind of sorted and the on the right side is bigger. So their common LCA is absolutely the root itself. There's other scenario is that if P is on the left, the right is on the Q is on the right, we absolutely gonna, the common ancestor is absolutely on the left side of the tree because both of them are smaller. So what we're gonna do is, when we know is 2 and 4, we're gonna try to find that we're gonna run this call recursively, call the root.left, treat the root.left as the root node, and then I'm going to continue to call the same function to find the common ancestor LCA on the left side of the tree. If that makes sense. So if you think about this way, then this is a question can be easily solved by calling the same function recursively. And this is, the algorithm is also really efficient. And if it's the same thing, if the P and Q both are on the right side of the node, I'm just going to look at the answer on the right side of the tree. So at that time, I'm going to pass this function and calling the same function, but instead of passing the root, I'm going to passing the root.right, because I'm going to look at the the right side of the tree to look for the answer, if that makes sense to you. So that's basically how we're going to solve this problem. And I'm going to show you how to do this in code. So if p double, it's basically you have to compare the value, not just the p. So if p double is bigger than root double, right, and q double is bigger than root double as well. So basically meaning that if both nodes are on the right side, I'm gonna call the same function to lowest common ancestor to pass because it's on the right side. So originally the parameter is root, right? Root p and q. I'm gonna pass to root dot right, and then the p is still p and q is still q. And then what I wanted to do is return the value of this calling this function's result, if that is the case. So that way this can run this call recursively on the right side of the tree and continue to look for the lowest common ancestor until it finds the answer, right? So then other scenario is if p double is smaller than root double and q double is smaller than root double. I'm just going to say that if both p and q are on the left side of the tree, what I'm going to do is I'm going to call the same function, but I'm going to return the calling the same function and lowest ancestor, and I'm going to pass the root as root dot left, right? And p is still p and p is still p and q is still q. And I'm going to call this function on the left side to find out until it finds the lowest common ancestor. And there's another scenario that we want to cover is that if the root is if p is on the left side of the tree, q is on the right side of the tree, and we already know any position we are at, like even the lowest 3 or with 9, it doesn't really matter. Their common ancestor is always the root node. So in this case, that we can just write it as else we want to return the root. So that's basically it for the code. If you think that this is helpful, please like my video and subscribe to my channel, and I'll see you soon with more Leetcode questions. Bye bye.